Okay, problem number 2. It's a much shorter problem than problem number 1. It says, draw a force diagram for each part of Wile E. Coyote's motion. Ignore air resistance. So starting at when he's running off the cliff, on part B it's just after he's left the cliff, and then part C just before he hits the ground. So remember, on part C he's still falling, it's just right before he hits that bottom ground. Okay, I didn't leave a good space to do this, so what I'm going to do for the video is put force diagram for A up here. So on part A we're doing this part of his motion while he's running on the cliff. Okay, so we're going to have a dot representing Wile E. Coyote, and we need to have all the forces that are acting on him. Okay, the first thing you guys should start with when you do force diagrams is the force of gravity. Most of you know to do that now, and the force of gravity always points downward. We know that's going to be present. Okay, now if it was only that force of gravity pulling down on him, he would fall down through the ground. So there is a supporting force that's keeping him up on that cliff. So we also have that vertical force balancing out that downward force of gravity. Remember, that's the force that acts at a perpendicular angle to the surface. That force is called the force normal. Okay, now I have seen some people that added, some called it an applied force, some called it a frictional force actually, to the right here, showing that he's moving to the right. You can add that, but it's not necessary in this problem. If we assume that he's moving at a constant velocity, then there actually won't be any force to the right. So we don't even need to include that. So really, just for that part A, you only need that force normal and that force gravity. That's good enough. Okay, part B, just after he gets running off the cliff. So he's left the cliff now, he's in midair, and he's just starting to fall. So for part B, once again we have our dot representing Wile E. Coyote. Once again, he's still on the earth, so he still has that force of gravity downward. That's what we always start with. But now, after he's left the cliff, there can no longer be that normal force that supports him from the ground. He's not touching anything. That normal force is gone. So for part B, while he's in midair, that's it, guys. It's just that force of gravity pulling him down. And for part C, just before hitting the ground. So he's still moving, he's still falling. He just hasn't hit the ground quite yet. So on part C, we have our dot. And to show those forces that are acting on him, once again we begin with that force of gravity. It's the same amount as it always has been. It's his weight. He hasn't hit the ground yet, so there's no normal force. Once again, it's only that force of gravity acting on him. Part B and part C look exactly the same. And that's it for number 2.